So let's look at this question. So we are to solve for x and y in this equation. So we have the cubic root of square root of a exponent 6 times b exponent negative 4 is equal to a exponent x times b exponent 2y. So this is an exponential equation. So we are looking at how we can find the values of x and y. So for this one, because it is an exponential equation, we shall employ some properties in indices. So we are going to apply some laws of indices here. So let's begin with our solution. All right. So I'm going to copy the question again. So I have the cubic root of square root of a exponent 6 times b exponent negative 4, which is equal to a exponent x times b exponent 2y. Okay, so questions like this, we can solve it in two ways. So these are the two ways. It's either we apply when you have radical sign. For instance, if you have this, let's say you have square root of a, this can also be expressed as a exponent half. If you have cubic root of a, it can also be expressed as a exponent 1/3. If you have the fourth root of a, you can also write it as a exponent 1/4. Good. So we are going to apply this property here, or we can also do it this way. Since this is a cubic root, we have a cubic root here and we have a square root here, we can take the cubic of both sides. So we can take cubic of both sides here and here. Okay, and after that we also take square of both sides because we have the cubic root and the square root. But I don't want to use that method. I want us to follow this procedure using square root of a, which is equal to a exponent half. So I want us to use these properties to solve for x and y. Now, since we have the cubic root of this, so we shall first deal with the cubic root. So if I'm to deal with the cubic root first, then I'm going to write square root of a exponent 6 times b exponent negative 4 all to the power of 1/3, because we are saying that if you take the cubic root of any digit or any value, it can also be written in this form. So looking at the question, because we have the cubic root of all this, then I can write it in this form, right? Good. Then I will maintain what is at my right side. I will not do any change, or I will not change anything there. I will just write what it is. Good. So since we have been able to change the cubic root in this form, then we also have square root. And remember, I said if you have a square root of any digit or any value, it can also be expressed in this form. That means you can also express the whole of this in this form. Okay, if that's the case, then I can proceed and write this. So I can write this. So I have a exponent 6 times b exponent -4, all to the power of what? Half, because this is in a square root. Okay, so it should be what? Exponent half. Meanwhile, we already expressed the whole as what? 1/3. So that one will come. Okay, good. So let's proceed. As for the right hand side, we maintain it as it is. So a exponent x times b exponent 2y. Good. Now, this is what we have. So let's look at the exponent here. So we have one exponent here and we have another one here. Remember, in one of the laws of indices, if you have this a exponent m and then you have another exponent outside, or let me write this as n. If you have this, you can write this as what? A exponent m n, meaning that whenever you have exponent here and another one here like this, we only need to multiply the two exponents. Okay, and that's what I've done here. So we are going to apply the same property here. Since we have half here as an exponent and we have 1/3 here as an exponent, then we are going to apply this property here. So we are just going to multiply this exponent. If that is the case, then I can write a exponent 6 times b exponent -4. Since I am multiplying this, then I'll multiply the numerators and then also multiply the denominators. So 1 times 1 gives me 1, all divided by 2 times 3 gives me what? 6. So it means that our exponent now is what? 1/6. Have you gotten that? And we keep on maintaining the right side. We don't want to touch it, so we maintain it as it is. B, so we have b 2 exponent y. Okay, good. So since we have this here, remember this law also. If you have, let's say you have a b, so let's say you have exponent m and then n, and you have one another exponent outside, so let's say 2, you have it here. So it means that this exponent is going to what? Multiply each of the exponents. Have you gotten it? It is going to multiply the exponent of each term. So we have this as a term, this is another term, and then we have what? Exponent here, exponent here. So once they are in a parenthesis or in a bracket, we can multiply this by this. So we can get a exponent 2m and then b exponent what? 2n, like this. Okay, so we can apply these properties here, and that's what we are going to do. So it means that we are going to multiply this exponent by the exponent of each term. So we have a as a term and another one as a term. Okay, if that's the case, then let me proceed. So I can write a exponent 6 times 1/6 times b exponent -4 times 1/6. Okay, like this. Then I will bring my a exponent x times b exponent 2y. Okay, great. If that's the case, then since we are multiplying, we can cross this out. Then we will have a exponent 1 times, because when we cross this out, it will be left with what? 1. And then here too, if we are to multiply this, then we can find a number that can divide 4 and at the same time divide what? 6. So if we get 2, we can divide 4 by 2, which will give us 2, and divide 6 by 2, which will give us what? 3, and multiply by 1. and then you are going to get b exponent negative 2 third. Great, because when 2 divides 4, it is what? 2 times 1 is 2. When 2 divides 6, it is 3. Okay, which is equal to a exponent x times b exponent 2y. Great. So now when you get to this point, then the rest of the work becomes very simple. So since we have a here, b here, so what we do is we only have to what? Equate corresponding terms. Okay, so we are going to just equate corresponding terms. Since we have a here and we also have another a here, we are just equating their correspondence. Okay, so it means that a exponent 1 should be equal to a exponent x. Okay, a exponent x, and also this b exponent negative 2 third should be equal to what? B exponent 2y. Okay, and in the laws of indices, or one of the laws of indices, whenever you have this exponential equation, if the base are the same, we only equate what? The exponents. Okay, when you have exponential equations and the base are the same, we only equate the exponents. So since here is a, yes, a, it means the base are the same. So our interest will be what? Equating their exponent. So if you have to equate the exponent, then it's going to be 1 is equal to x. Okay, which can be written as, therefore, x is equal to what? 1. Okay, good. So since we can conclude that x is 1, then we can move on to the b part. Okay, so the same thing here. Since the b's are the same, then we are just going to equate the exponent. So we will have negative 2 third is equal to 2y. So we only have to make y the subject, then we can divide both sides by what? 2. Okay, so that we can have y to be what? Negative 1 third. Okay, great. So the question asks us to find the values or solve for x and y. So it means that the value for x and y are what? 1 and negative 1 third respectively. Okay, so this is how questions like this you can go about. Very simple, right? Good. So when you have such question, you just have to take your time and go through all this process, and you get the answer right. All right, so I'm your facilitator, Evans. Okay, the name of this channel is Mazwis TV. So I will be grateful if you can subscribe, like, and share for me. Don't also forget to add your comment under the comment section. So meet you next time. Thank you.